We are given this function a of t, which represents the amount of money in the account after t years. So basically, a of t represents the amount of money in the account after t years, and this is given as a naught. A naught represents the initial amount of money in the account, and this k naught, I'm sorry, this k represents the growth rate, and this t represents the time in years. So let's utilize the given information to find the time it takes for the money to grow to $450. First, let's put this initial amount. This is represented by a naught in the amount function. So I can put this a of t, and this equals a naught is 200 e raised to the power of kt. Now let's use the second information, which says that the money grows to $300 after 5 years. That is a of t equals 300 when t equal to 5. So let's plug in this information into this model so that we can determine the value of the growth rate constant k. So I'm going to replace a of t by 300, and this equals 200 e raised to the power of k times of t is replaced as 5. Now divide both sides by 200. We get 300 divided by 200, and this equals we have 200 e raised to the power of k times 5 is 5k, and this divided by 200. So let's do this cancellation. We cancel this 200 in the numerator with 200 in the denominator. In fact, we can cancel this 300. This is 3 times 100, and 200 is 2 times 100. So we cancel this hundreds and hundreds, and so finally you are left with the fraction 3 by 2 on the left side. So I put 3 by 2 on the left side, and this equals e raised to the power of 5k. And now to determine the value of k, we have to apply natural logarithm to both sides. So let's apply natural logarithm. And when we do that, we get a natural logarithm of 3 by 2. And this equals a natural logarithm of e raised to the power of 5k. Now we use the property of natural logarithm, that is the power rule of natural logarithm. And this means this 5k will get multiplied in front. So therefore we can write this as natural logarithm of 3 by 2. This is we have on the left side, and this equals 5k times of natural logarithm of e. Notice that the value of natural logarithm of e, and this is exactly equal to 1, and this means we can replace this natural logarithm of e as 1. So therefore I can just remove this, and 5k times 1 is just 5k. So we only have 5k on the right side. Now we divide both sides by 5 so that we get the value of k. And so I rearrange for k, and this equals natural logarithm of 3 by 2, and this has to be divided by 5. So we have determined the value of k, which equals natural logarithm of 3 by 2 over 5. Let me now rewrite this value of k in a little bit simple form. So we write k equals natural logarithm of, we know that 3 by 2 equals 1.5 in terms of decimals. So I'm going to put this 3 by 2 as 1.5. So it becomes a natural logarithm of 1.5 over 5. We can use this value of expression for k, and we have to substitute this into the amount function. So let me put into the amount function. So we have amount function a of t, and this equals 200 times e raised to the power of kt. Let me replace k by this expression. So it becomes a natural logarithm of 1.5 divided by 5 and this has to be multiplied with t. So this is the amount function that we have obtained after finding the value of k. Now we have to determine the value of or the time value such that the amount grows to 450. And this means we replace a of t by 450 and then determine the corresponding value of t from this function. So when I do that, I put 450 for a of t, and this equals 200 e raised to the power of natural logarithm of 1.5 divided by 5, and this is multiplied by t. Now let me first divide by 200 both sides. So divide by 200 here and also divide by 200. So these two 200s gets cancelled, and here I can just simplify this. This is 45 over 20. So this equals 9 times 5, and this equals 4 times 5. This means I can divide the common factor 5. So it reduces to 9 fourths. So I put a 9 fourth, and this equals e raised to the power of natural logarithm of 1.5 divided by 5, and this has to be multiplied by t. Now to determine the value of t, once again we have to apply the natural logarithm to both sides. So let's do that. We apply natural logarithm to 9 fourth. So it becomes a natural logarithm of 9 fourths, and this equals natural logarithm of e raised to the power of natural logarithm of 1.5, and this is divided by 5, and this quantity multiplied by t. And we know that we can apply the power rule of natural logarithm. So therefore this complete quantity comes in front and gets multiplied with natural logarithm of e. So therefore we can write this as natural logarithm of 9 fourths. We have it on the left side, and this equals, we put this complete expression in front, that is natural logarithm of 1.5. This is divided by 5, and this multiplied by t, and then we have to multiply with natural logarithm of v. So we already know that natural logarithm of e equals 1, so therefore we can just ignore this quantity, and this is the expression that we have on the right side. And from this we have to determine the value of t, and this means we have to divide both sides by this quantity. So let's do that. So therefore I rearrange for t such that it comes on the left side. So we can write down the equation for t. This equals a natural logarithm of 9 fourths, and this is over natural logarithm of 1.5, and this is divided by 5. And so we can put this expression into the calculator, and when we do that, we get the value of t exactly equals 10. So therefore we now say that t equal to 10, and this means it takes 10 years. This is basically the answer to this question, for the amount to grow to 450 dollars.